A quartet of small satellites flew high above California's Mojave Desert on June 15 on a demonstration mission to study the launch environment all the way from liftoff to landing. The 4-inch Cube spacecraft, better known as CubeSats, are being developed to help simplify and lower the cost of small satellite missions that could fly on smaller, dedicated rockets. All 4 CubeSats were outfitted with special instrumentation to monitor flight characteristics aboard the Prospector 18 rocket, built by Garvey Spacecraft Corporation. One of the satellites, CP9, belongs to California Polytechnic State University at San Luis Obispo. It flew alongside StangSat, created by students at Florida's Merritt Island High School.
We're now bringing together students, experiments from other centers onto a launch vehicle. So it's very exciting to see these young people move into industry, build a rocket, and now fly in students who have built satellites and merge these two together.
Both CP9 and StangSat were designed to work together, recording the launch environment and communicating with each other through onboard Wi-Fi. They're slated to fly aboard a Falcon 9 rocket during SpaceX's 5th commercial resupply services mission to the International Space Station.
We are having our first test for the StangSat to help show that everything we've done up to this point has been correct, and that our ideas are sound and our techniques are sound, and that what we are planning to do is in fact going to work.
Another satellite called PhoneSat was built by NASA's Ames Research Center. It relies on smartphone features like power, memory, onboard camera, and small size as a platform for low-cost spacecraft design. And the Rocket University program at the agency's Kennedy Space Center contributed the Rubix 1 satellite, short for Rocket University Broad Initiative's CubeSat. Rubix was outfitted with a suite of instruments to monitor the performance of a new lightweight deployer built by Tyvak. Cal Poly also serves as a liaison between the payload providers and NASA's Launch Services Program and oversees the satellite's integration with the rocket. In the final days before liftoff, the Prospector rocket arrived at the Friends of Amateur Rocketry launch site in the Mojave Desert. The CubeSat carriers were attached to the bulkhead in the top of the rocket. Finally, the day before liftoff, the vehicle was raised into a vertical position, poised for flight. Launch day dawned bright and early, and final preparations began. At 10:52 a.m. Pacific Time, the rocket's single liquid-fueled engine ignited, and the mission was off to a roaring start, reaching a peak altitude of about 9,000 feet. The rocket's parachute deployed prematurely, and the vehicle continued on its trajectory, coasting and tumbling to a hard landing on its side. But despite the rough ride, all 4 CubeSats were recovered. PhoneSat and Rubix received data in flight, but sustained structural damage. CP9 and StangSat fared better, and their teams are working to recover as much information as possible.
Right now they're taking apart our satellite to see and analyze what happened. We're taking very small steps and documenting everything, taking pictures of everything to make sure that we could recreate the scenarios and we could always look back to it.
A flight data recorder aboard the Prospector rocket also may hold important clues.
We're able to recover my data logger payload, a little broken, but I was able to get the data card off of it, and so we do have data, which is a success.
Rather than a setback, the flight is considered a success and a valuable learning opportunity, giving the teams the chance to test their designs in an unexpected environment.
On the plus side, talking to the principal investigators, the payload folks, most of them got data. Interesting data, probably more than if we'd had a nominal flight, so they're all busy looking away, trying to see what they can do, which as a learning experience is great.
More flights are planned as NASA and its partners continue the quest for a faster, low-cost alternative by delivering CubeSats into space as the primary payloads aboard smaller launch vehicles.